All right, folks, it's Bass Action back in action here. On this page of notes, we are going to take a look at function composition and finding the domain of our composite functions. So got a couple warm-ups here at the top of the page. So let's just take a look real quick because what we're going to do today totally relates to these two warm-ups here at the top. So on warm-up number 1, we just want to quickly review evaluating our function. So for example, I give you f of x and g of x. I ask you to find f of negative 3. So of course that means that we're only going to put the negative 3 into the f function. So let's just do that very quickly. If I put my negative 3 in there, I'm going to have my negative 4, and I'll have my negative 3 squared plus my 3. So I can do some of this in my head, but we'll write it out. Negative 4 times my 9 plus my 3. So I've got a negative 36 plus a 3. In other words, I get negative 33. So pretty straightforward there. On our second warm-up question, we want to find the domain. So remember, our questions that we've been asking ourselves so far is, do we have a fraction and do we have an even root? So on this problem, we can see that yes, we do have a fraction. So our only concern on our fraction is where this denominator might become 0. Other than that, all other values would be included. So we can clearly look at this and figure out that our denominator would become 0 at 9. So we could write our answer in our set notation is x such that x is not equal to 9. If you really wanted, you could certainly write this in interval notation, or if the question asked you to write it in interval notation. So in other words, we would go from our negative infinity to our positive 9, not inclusive, and then start again at our 9 to our positive infinity. Personally, I think the set notation on this would be better, but you never know what the instructions might ask. So now, taking a look at our function composition, we first want to think about how you might see this written for us. So when we see our instructions for this, you might see these written like this, or you might sometimes see it written like this. Okay, so our first notation, we're going to read this. I'll write it out for you. It's read f of g of x. And when we're looking at this first notation, basically what we're doing is every time we see a parenthesis, we say the word of. So f of g of x. This other notation, very uncreatively, is often referred to as fog because we've got this little open circle here and it looks like it spells the word fog. So we sometimes see this as fog and goff. So that's our fog notation. They mean the exact same thing. So down here, if we look at example 1a, it has written in the fog notation for us. So the first thing that I typically like to do is I like to write it in the more traditional approach. I think it's a little easier to see what's happening here. So I typically just rewrite this problem as f of g of 1. What that allows me to do is more clearly see that what I'm going to first do is evaluate from the inside out. So the first thing I'm going to do is find g of 1, similar to what we did in our warm-up. So if I want to find g of 1, I'm going to go to my g function, and I am just going to do my 4 times my 1, or 4. Now that I have that answer, I can take that answer and substitute it in, and actually then find f of 4. So what I found here is now then what I will evaluate next. So if I find f of 4, I can now put that into my f function. So looking up above at my f function for this problem, I can see I'll have 2 times 16 minus 3, so 32 minus 3, or in other words, 29. I can flip this same direction around, and notice I wrote it in the other way this time, but I can flip this around, and now I have g of f of 1. So again, we're going to work from the inside out. We're going to find our f of 1 first. So let's find f of 1. Just plugging 1 into the f function. You do have to be really careful that you're evaluating the proper function. So f of 1 will give me a 2 times a 1 minus a 3. So 2 minus 3 is, of course, -1. Then I am going to now go to the outside, and now I'm going to do g of -1. Remember, we're just taking our prior answer and subbing it in. So now if I do my g of -1, I'm going to have 4 times a -1, or in other words, a -4. So you'll notice that all I did on these two problems was reverse the order of the composition, but I got dramatically different answers. So to fill in our blanks here down below, where it says, are f of g of 1 and g of f of 1 the same? And the answer is clearly a giant no. So does the order it's written matter? Absolutely yes. Okay, keep that in mind. So the order that we read these certainly does matter. All right, now that is if we want to actually evaluate a function composition. And you can tell the difference between those instructions and what we're about to do, because on example 1, I actually had actual x values here. So I had numbers that I was evaluating. As opposed to on example number 2, when we come down here below and it asks us to find a function composition, it wants us to find f of g of x. And when it asks us to find this f of g of x, that means that our final answer is going to have an x in it the vast majority of the time. It's certainly possible it could cancel out, but in general, our answer should have an x in it. We're not evaluating for a number or solving any kind of an equation. It's a really important element there. So let's take a look here. It wants to find g of f of x. So again, I typically like to write this out first. It helps me see the inner and the outer a little better. So I would rewrite this as g of f of x, okay? What that's going to help me do is figure out what's my inner function and what's my outer function. So just as you would expect, this is my inner, and then my g function is my outer function. So what I like to do is I like to write that outer function. It's sometimes helpful for students to see that outer function written first. So I'm first going to write g of x. And my g of x is my 2x plus 3. And of course, if I asked you to evaluate g of 7, you would replace this x right here with a 7. But instead, I'm asking you to find g of f of x, which means where you see the x, we need to insert the entire f function. So let's go ahead and do that. And I'm going to even color code this. It might make this pop out for you a little bit better. So that x, instead of being replaced with a number, is going to be replaced with the entire f function. So I've got an x squared plus a 3x minus a 1, just as if that was a number. And then, of course, I still have the plus 3. So all of these elements of the original g function have to be there. So if I want to continue solving this and finding this function composition, I'm going to distribute my 2. So I'll have my 2x squared plus my 6x minus my 2, of course, plus my 3. And then I'm going to simplify this and collect my like terms. So 2x squared plus 6x plus a 1. This is g of f of x. Now, it's really important that you understand that we do not solve. We stop right here, and our answer is this actual new function. All right, on the next page, we're going to dig a little deeper, do some things more complicated, and find the domain.